right. Hello, everyone. My name is Dr. Gianmarc Grazioli. I'm an associate professor of computational chemistry at San Jose State University in the Department of Chemistry. And I'm thrilled to be here today to tell you a bit about getting started with Python data visualizations in Google Colab. So there's a variety of reasons why I think this is a really useful thing to be able to do. And it's also really timely. There's kind of never been a better time to get into this sort of thing. So let's see, before we kind of get into the presentation in detail, I want to kind of give you all a heads up. So because I'm a solo presenter today, I still wanted to bring backup. So I have the great pleasure of working with a lot of really smart students from San Jose State University who work with me all the time writing Python code that they have used ChatGPT to help them optimize. I just realized my camera's a little crooked. There we go. Forget it. Um, so they we'll just roll with it. So they so I have about four of my students with us today. And the idea is that I'm going to lead the workshop. I'm going to have us do a bunch of hands-on coding together. And the thing about a bunch of people writing code together is it can take twists and turns in all sorts of different directions. People can have errors come up that are uniquely theirs. That sort of thing happens all the time in this sort of situation. So my strategy here was that, well, let me bring in a couple of ringers in the group that are my research students who are very skilled Python programmers, and they use ChatGPT all the time with Python programming. So basically, if you have any problems as we start doing some coding examples, please post your questions in the chat. So my students are keeping an eye on the chat there. So if you post a question in there and one of the other participants starts answering it, it's probably one of my students. All right. Uh, let's see. So let's get started here. So why Python visualization? Why now? Why am I such a big proponent of this? Well, um, Python is free. It's open source, it's reproducible, it's shareable. So, if you use something like maybe MATLAB or Mathematica, right? Great products. I use Mathematica a lot. I like it. But you have to have a license to use it. So, a lot of universities do have a license, so it is pretty accessible. But with Python, it's free, it's out there. So anybody can use it. So if you were to publish a paper and you want to share your data, or maybe you want to work with a collaborator, whatever the case may be, by creating your data visualizations using Python, you're part of a community. And I think that's an amazing thing. And it's never been easier than it is right now to become a part of that community. It's ideal for scientific data analysis. So one of the big Python libraries. So basically, if someone creates a functionality that you can use in Python, a lot of times if somebody makes something for themselves and they're like, this is pretty useful, I think I'm going to share it. I think a lot of people could benefit from this. Well, then people will often create a library and publish that and share it publicly. And you don't have to be a computer scientist to do that. So obviously, there's an advantage to being a computer scientist for doing that sort of thing. But I think it's either Pandas or NumPy. These are kind of two of the most famous libraries. I think one of the main developers for, I want to say NumPy was, I think, a neuroscience scientist. So not a computer scientist. So there's all kinds of different scientists use Python, and they're creating tools that are specialized for your field because it's people from your field making them. So it's an amazing community. I really recommend you get involved. I think, there's always going to be people that want to sell you something that you can point your mouse at and click on and it does things for you. And I understand the temptation, but, I look at it as like, as a computational chemist, I'm a particular flavor of physical chemist. So I think of things, in a physics kind of background. And I look at it as getting over an energy barrier, right? So you're in one state where you have to put more effort in to make your data visualizations, but maybe you don't want to put that extra effort to go over that energy barrier into the lower lands, right? Into the lower energy state where now it's easier to do all of your data visualizations moving forward for the rest of your career. So this is me kind of cheerleading you on here today and say, like, it's worth it. Put the effort in, get over that activation barrier and land in the lower energy state where it's easier to make data visualizations moving forward. So, fine, you'll have to do some work to get over that hill, but it's worth it. Um, so, Python is one of the most readable programming languages ever made, if not the most readable. It's up there, right? It's one of the most readable languages. Um, and ChatGPT writes excellent Python code, right? Is it perfect? Can you count on it 100%? Of course not. No, it's gonna make random errors all the time. It's gonna misunderstand things. Sometimes it can send you kind of down an unproductive path or a less productive path. So no, it's not perfect, but it is very good. And if you know what you're asking for and you're asking for small enough chunks of things, that tends to be when it performs the best. And just as you do when you're developing code without using an AI tool, test as you build. Make sure it's really doing what you think it's doing. Don't just assume that it's doing what you think it's doing. So anyway, the readability of Python and the fact that ChatGPT can write it so well means that being able to read Python is actually that can get you really far, right? Even if somebody gave you, if somebody did one of those famous coding interviews where you go up to a marker board and you have to write out code, maybe you could never hope to do that. But if somebody shows you a Python code, say, hey, what does this do? You know, pretty quickly you can kind of get up and running with that level of understanding. And since we have large language models that will generate that first attempt at a code that you want, that's actually more valuable than it has ever been. So now why Google Colab? So there's different environments you can write Python code in. Jupyter notebooks are really popular. Basically, I would compare Google Colab is to Jupyter Notebook what Google Docs is to Microsoft Word, right? You can have a document that is saved on your local machine and you're doing things to it locally on your machine, or you can have something on the cloud, right? The cloud is really just other people's computers, but that's besides the point. Um, that's the idea with Google Colab is that you've got a Jupyter Notebook running on Google servers, right? So they've got all sorts of libraries already installed. You can even install libraries on there. I'll show you how to do that shortly. But you have a lot of power at your fingertips by using Google Colab. You don't have to install anything on your computer to do Google Colab either, because sometimes installing software is harder than using software, depending on, dependencies and other things like that. Um, and also, it's nice to be able to save and share your work through Google Drive, and with Google Colab, that's very easy to do. So I'm a big proponent of using Google Colab. Another thing that's nice too is sometimes like there's different ways of teaching people how to code, and another great way to teach people how to code is like you create environments, and like everyone in the class works in the same environment, and then everything should work well. So the reason I decided to go with Google Colab today instead of creating some sort of environment that it would be the same sort of deal for everyone is I wanted you to take something with you that you can keep using, right? I don't want you to like kind of do something in the workshop and be like, oh, that seemed like it'd be cool, and then you never come back to it. I want you to come out of this workshop thinking like, I can do this. I'm gonna go create my own Google Colab, and I'm gonna upload some data. I'm gonna try plotting it, right? I really want to inspire you to do this on your own. And it's pretty easy to just create a Google Colab and just get started. Okay, so um, I feel that a little bit of theory is always important, right? I think there's a famous incident where somebody was asking Nikola Tesla about Edison and how Edison's was basically you just got to try everything, right? Just keep at it. And Nikola Tesla said something to the effect of, if he knew a little theory, he could have done much less work, right? So I think a little bit of theory of how computers work and how Python works, I think is worth talking about, right? Because we don't want to just have ChatGPT do everything for us. We don't understand what it's doing. So there's a few computing concepts that I wanted to discuss in the form of a presentation right now before we get into the hands-on stuff. So I've saved plenty of time for the hands-on stuff, but I do want us to get through a little bit of theory stuff here because, like Nikola Tesla would advise us, this is going to save us a lot of effort if we know a little bit of theory. So I'm going to make sure I have the chat window open. If questions come up or like if something didn't make sense, like maybe I'm talking about something in a familiar way and you're like, I've never heard that before, please feel free to mention something in the chat. All right. So I'll try to keep an eye on that. And yeah. So, all right. So I want to talk about objects. So you're like, wait, you told me I didn't have to know anything about programming for this thing, and now you're talking about object-oriented programming. Well, Yes, but not in any particularly deep way. So, I often go back to cars, right? When I have to do an example of anything, I like to talk about cars. Um, so let's say there's a library where you can that called cars that you can do all sorts of car things with in a programming language. So if you import cars, that means, okay, in my session, I have this Python session running on a Google Colab. I want to import this library cars. And within that library, there's a particular object that is called a Mustang. And so let's say you want to create one particular instance of a Mustang that's going to be your Mustang. And, maybe you like to name your car, right? You want to, it's an orange Mustang, you want to name it Julius, right? So maybe this is something somebody would do. So we have Julius equals cars.mustang and then some data about the color inside of parentheses. So important thing to note is a single equal sign like this. Think of it as the assignment operator. It's taking the thing on the right and storing it in the variable on the left. So I've created a particular instance of a Mustang named Julius. Right? So there's a type of object called the Mustang that came from the cars library, and this is one particular instance of it that we're going to name Julius. And you notice the inside of those parentheses, we've assigned a color to it. And so there's three numbers associated with that color. Does anybody know what those three numbers are? I also I'd like to ask a lot of questions. Type it in the chat if you know what those colors represent or what those numbers represent. Good. Yeah. So good bit of people know. Very nice. RGB, red, green, and blue. So any color you see on a computer is some combination of red light, green light, and blue light coming from the LEDs. And those numbers range from 0 to 255, which is the range of a positive 8-bit integer. So those are actually the values for that car. I used PowerPoint to pull those numbers out. So we've created an instance, Julius. And so you can say, okay, the relationship between Julius's color and Julius, that's an attribute, right? It's something about Julius. Julius happens to be orange. Are all Mustangs orange? No, but Julius is, right? So this is an object. So Julius's color is Julius's attribute. Now, so what are methods? Well, here we've called a method. We said Julius dot do a burnout, and notice the parentheses there, right? Just like f of x. If you were going to write f of x in a calculus course, you have parentheses around the x, right? So if you have a function, you have parentheses as the thing that things get passed into. So this is an example of a method. So we have an object we've created called Julius, and that object can do a lot of things. One of the things it can do is a burnout. So if we say dot do a burnout, it does a burnout. So doing a burnout is one of Julius's methods. And so objects can have lots and lots of attributes, lots of methods. There's a lot that you can have stored in an object. It can store attributes in the form of data. It can store other objects. An object can have other objects, right? Maybe you have inside of the car object, you have an engine object, and and then that engine has attributes like how many cylinders or peak red line, whatever, things like that. So this is what an object is, and Python's an object-oriented language. And as I'm teaching you how to write code that an AI helped you write, you're going to see a lot of times where it says like something it made dot something else. The way it says Julius dot color with no parentheses because it's an attribute, or Julius dot do a burnout with parentheses because that's a method. That's something it can do. So I want you to be familiar with that so that when ChatGPT gives you Python code, it has that kind of thing. You say, ah, there we go. It's accessing an attribute from that object. It's calling a method from that object. Any questions about objects? All right, cool. So let's keep going. In fact, let's open up a Google Colab notebook. So we're already going to start, getting our hands dirty, so to speak. Let's see. So there we go. That was driving me nuts. Okay, so let's take a look at. Let's get out of here. I'm going to switch the view. Yeah, I'm still sharing. Oh, hang on. I just saw a question. So somebody asked a question about objects. They said, are objects like cases in a data set? No, not quite. I'm glad you asked this. So let's see. Objects are like cases in a data set. No, I think like it'd be more like if you loaded a data set into a Python notebook, I would say that the whole data set could be an object, and you can load it into a specific type of object called a data frame. But every piece of data in there is well, it's I wouldn't think of that as an object. No, it's more cases in a data set. Now that's just more like rows of data. So we'll get into that a little more, but if you feel that I think my your question will be answered by the end once you see some more things. If not, please repeat the question later and we'll address it again. Thanks a lot, Omira. Okay, so let's see. So let's get this open and I'll put this in reader view. Where is it? Reading view. All right. So here we are here. And now I'm going to get a Jupyter notebook open. So let's see. I had created, let me grab that real quick. Oh, actually, while I'm thinking of it, I'm going to go ahead and share a link with you all right now. So share, copy link. You don't have to do anything with this link right now, but I want you to all have it and let me know if people need it later. There's that link. This is just a data set that a couple of data sets that I've made public to y'all. But okay, so let's get in here. I'm just going to create a new one. So because my Google Drive account is enabled for it, I can create if I right click where you want it to be and then go to more and then Google Collaboratory, there we go. If I click on that, then a Google Collaboratory will open up. Again, just like if I wanted to create a new Google Doc or something like that, it works the same way. But this will open here. Let's see. And so the first thing you want to do is change the name because it's called Untitled. That's not a great name, obviously. So I'm just going to call this In Session Scratch. So if I call that In Session Scratch, so this will be like our scratch paper for being able to just kind of try out ideas and things like that. So I'll put that here and let's start trying some of the examples that come up in the slides. And I encourage you all to do this as well. Try the examples. In fact, I'll try and paste them into the chat, and then you should be able to copy and paste it into your Google Colab. So actually, let me see. Can I see everybody right now? No, no, I can't. Uh, so everyone, let me see. I don't think I can see all of the participants. No, that's okay. Okay, somebody hasn't been able to open a collaboratory. Okay, so opening up a new collaboratory, one more time, I'll do it. You have to be in your Google Drive account first. All right, so if I'm in my Google Drive account, I right click. Uh, the usual suspects will come up, right? Google Docs, Sheets, whatever. If you go to more, you should be able to choose Google Collaboratory. And if you can't, then it's probably because you didn't activate it like was in the email. So go back to the email for that. And also, some of my students who are in attendance, maybe you could help Amira a little bit. So I think this is a good example of one. Well, actually, let me see. So one more time, right click, more, collaboratory. And that's it. And you've got one. So that's all there is to it. So hopefully you've got it. Let's see. Attendees. Oh, maybe I can see responses. Are you able to do thumbs up and things like that? Can I get a thumbs up if you were able to open a Google Collaboratory? Hopefully you were able to do this. Never received instructions. Okay. I'm gonna go. Let's see. Okay. Okay, got a few thumbs up. Cool. Oh, good. Some folks got it going. Let's give this another minute because I don't want to. Okay, good. A lot of people have them. Let's see if I found the link in the email easier to open a new collaborator. Okay. Thank you for sharing that information, Elizabeth. So maybe you can try that. Let's see here. Okay, got it. Okay, perfect. So thank you, Elizabeth. That's great. Okay, so once you're logged into so you have to have a Google Drive account. So if you have Google Drive, that's step one, right? You have to have Google Drive. You can't do today's activity if you don't have Google Drive. So if you don't have that set up, hopefully you do. I think probably people have that. But once you're logged into Google Drive, you click on this. Here, I'll click on it too. If you click on that link in the chat that Elizabeth just put there, collab.research.google.com right here, right? And then once you've done this, I recommend like, maybe click on upload and then drag, you know what, I'll put in that shared drive. Let me put something in the shared drive real quick too. Um, Actually, let's do this. I'll just drag untitled in there. There we go. So you should have a Google Colab notebook in data for participants now. So you could like click on that and then download it and upload it. But I think if you go to this site while logged into Google Drive, you should be okay. So anyway, oh, thank you, Alan. I appreciate it. Alan's one of my students, and so is Joel. Thank you, Joel. And Hui as well. Thank you. I appreciate you guys helping. Thank you. All right. I'm gonna keep going. Um, because I do want to get into working with some more serious data sets. But let's start out with the ones that we are using just to get the hang of things in this current session. So let me put this back off the screen here. All right, let's see. Thank you again to my students for helping out. Okay, so we've got this in session scratch here, and we have an example that I have in the slides here. And basically, it's going to give us a way to talk very tangibly about a few things, right? So first, we're going to declare a variable x. Nice thing about Python, you don't have to tell it what kind of variable it needs to be. So I'll just say x equals, and then Python interpreter will figure out what it is. So if I give square brackets like this, Python knows this is a list. So here I've defined a list. Let's just run that first. Oh, by the way, too many sessions. Oops. Apparently let me close one of these here. Yeah, I can close that one. That's fine. Oh, that's interesting. Let's see here. Cancel. Let's try it again. Oh my goodness. So understandably, I believe Google monitors how many Google Colab sessions you have running at once. This has never come up for me before, so of course it does in the middle of a presentation, naturally. Anyway, let me try closing this and opening it again. Maybe I could say manage sessions. Yeah, I can close that. I can close that. And there we go. Okay, now this should run. If I run that, there we go. So the way you run a cell is so you click in the cell. So my cursor's in the cell right now, right? And if I hit Shift Enter, that's how you run the cell. Um, Also, another thing about Google Colab, there's different types of cells. So this right here is a code cell. I can add a text cell as well. And if I add a text cell, this is a text cell. So then, you can make things look nice. You have all the, we can toggle heading or format as code. There's all these different things you can do with a text cell. But we don't need that right now. I just wanted to show you that that's a thing. So make sure if you're going to write code, it's in a code cell. And if you're going to write something that looks not, and you want it to look nice, like instructions for a student or something, put it in a text cell like this. These are also known as markdown cells. So that's kind of another name that when you run these things locally, they're typically called that. Okay, so by having x equals square brackets, and then we have a bunch of these numbers here. If I hit Shift Enter, That executes that cell. And once it's executed, now the Colab notebook knows that this is has defined this, right? So if I print X, there it is, right? So I can print that out. But another thing I can do, as I mentioned, there's all these objects in Python, right? Python's an object-oriented language. So is X an object? Yes, it is. X is an object and it's a list. But if I'm ever not sure, if I'm like, oh God, what type is X? What type is X? Well, you just type, right? There's a function for this. X, shift enter, and it tells you what it is. It's a list, right? So one thing I always tell my students in my courses where I teach the Python programming is always be very, very conscious of like what data types are going into my functions, what's coming out of them, right? How is my data being stored in different types? Okay, let's see. Let me check on the chat a little bit because there's a few questions here. What spaces are important and what are optional? What spaces are important? What are optional? I'm guessing maybe you mean white space in terms of the code. So there's some code that like the spacing does matter. Like it won't execute properly if the wrong number of spaces are there. But we're actually going to we're going to offload some of that to ChatGPT today. But like for loops is an example where, on the, for this and that, colon, new line, indent four spaces, right? That's an example where spaces are important. But right now, X is an object. It's an object of type list. And X, I can do this. I can say X dot append and pass to that a 4. So type it in the chat. Is append an attribute or a method? So type either attribute or method in the chat. Is append an attribute or a method? Good. Yes, it's a method. Very good. Right? Because it did something. Because now watch, if I check the type, it's still a list. But there's a built-in function, global function for Python called print. I can print it out. Look, now there's a 4 in there. So it appends it, right? Just like an appendix is something added to the end of a book. If you append something to the end of a list, this is the way to do it. So lists, X is a list. That's the type that it is, and it has a built-in method called append. So that's what we have here. Okay, let's keep going. Next, other data types that we have. Int is an integer, right? So nice thing about Python, you don't have to explicitly tell it something's an integer. It'll just guess that. So if I say like my int equals 5, and then I do type of my int, it tells me it's an int. But now what if I do this? I put a dot there, and I run that. Well, now my int is a float. It's floating point. That means it can accommodate decimal things after the decimal place. So this is a floating point number. It's a different thing, and that's how we store decimals is with a float. Another data type we have is a string, abbreviated str. So here we have one. We have NaCl, appropriate for a computational chemist. And let's do well, let's check its type first, right? So we use the type function, and we see that NaCl is indeed a string, right? Now, this string, is this an object? Is a string an object in Python? Just take a guess. Type yes or no in the chat. Do you think they think a string's an object? Is a string an object? So basically, I'm asking, does it have attributes and does it have methods? Good. Yeah, everything is. Yep. It is an object. So if I do dot lower and I run that, makes everything lowercase. So just even defining a string, I didn't even assign it to a variable. I just typed a string in there. It's an object already, right? So if it's in quotes, it is a string. And so strings are just interpreted by the interpreter as just plain old text, right? So in the land of strings, 1 plus 1 equals 11. All right, I'll show you. Right, if I say one, whoops, plus one, right? In strings, that's 11. I'm not adding the value one plus the value one. I'm adding the character one to the character one. So it just sticks them together. So the operator, this plus operator, is used differently on strings than it is with numbers. So a Boolean is either true or false. So that's and you literally just type out true or false for that. So if I and you could there's also logic. So if I say like true or false, right? If there's any philosophers, right, they'll know that that should be true, right? Because for an or statement, the output is true if either one is true, right? Let's see. Zoom out a bit so we can see more lines at once. Um, sure. I mean, that's all I have. Oh, I see. The ones that I went. Yeah, good idea. Good idea. Got it. Hopefully that's a good amount of zoom. Like to make it easier on your eyes. Okay, what else do we have? So Boolean, true or false, right? So you can have a variable that, did I water the garden, true or false, right? So it could be a variable named watered, and it's equals true or it equals false. Lists, you've seen a list, and dictionaries. Dictionaries are great. I really like dictionaries. You can store things in terms of keys and values, and you'll see ChatGPT use them a lot. So think of a dictionary like just a regular dictionary, like a book, right? You look things up by their name. So if I do like elements, right, and then let's open a periodic table because if I get an atomic number wrong, I mean I'm never gonna hear the end of that. So I'm gonna look off of here. There we go. So let's do elements, and we want to look them up by the name of the element, right? So if I do B and then colon 5, and then I do C colon 6, and then N colon 7, right? I've defined a dictionary here. So if I have my elements and I want to look up, like, oh, what was the atomic number for carbon? Oh, there we go. I just type in carbon and it returns the value. So you look things up by the key, it gives you the value. So I think this is another important thing to spend some time on, is just know what a dictionary is. If you see curly braces, that's a dictionary. So, right now, I'm just giving you a crash course. You don't have to retain all of this. I just want you to kind of be conscious of these things before we start getting ChatGPT to write a whole bunch of code for us. And that's why I made this thing 2 hours. I thought, let's do kind of some theory first, and then we'll really get into it. Okay, got a question. Somebody's completely lost. Let's see. So Missy said, I'm completely lost. Will there be another version of this webinar for people who have no limit of coding? Okay. Yes, this will get posted to a video, but thank you for telling me this. What can I clarify? Is there something you want, even just something you want me to repeat? Happy to do that. Add some clarity here. All the terminology. Yeah, it's a lot of terminology all at once. Um, yeah, mainly. Okay, so the main things to kind of like be able to hold in your head right now, right? If you've never heard the word string or float or all these things, there's different ways of storing information, right? Like an integer is not a float, it's not a string, right? You can store things as plain old text or numbers, and then if it's a number, okay, does it have a decimal or no, right? And then there's also different ways of storing sets of information, and one of these is a dictionary, one is a list. So don't worry about it if you can't remember that later. Just know that there's different ways of storing this information. And also an object. Just go back to the car example. Objects have attributes and methods. There's either something about the object or the object can like do something, and usually on itself. But thank you for pointing that out. Let's see. I don't know. Oh, you'll get so it takes time, Missy, but stick with it. Stick with it. And we'll definitely have more time for questions too as we keep going. But like just there's oh I can't remember who said it. Some famous I think it was a famous physicist where like when you're learning something new like it's not like drinking a glass of water out of a glass where you do expect every drop of it. to make it into your mouth, right? It's more like drinking from a fire hose, and like you drink what you can, and then you go back and you get some more, and eventually you get there. So keep at it. It is not too late. You can absolutely pick this up. And once we have ChatGPT writing some code for us, I think we'll be able to kind of keep asking questions. But again, just wanted to kind of go over a little bit of basic vocabulary. Um, these are all libraries. So again, if you think of all the functionality you can do in Python, everything that Python can do, it's not like Microsoft Word where you start up Microsoft Word and everything it can do is available to you, right? You ever notice how long it takes like a Microsoft Word document to open up? It takes forever, right? Compared to like just a plain text document. It's loading all this functionality that you're not going to use, right? With Python, you only load the functionality that you're going to use. And that's what a library is. So just want you to have heard these names before. NumPy, famous library that's used for numerical stuff, really good with matrices and things like that. Pandas, that's Python and data science. I think that's what it stands for. So that's sort of the big one with data scientists. It's really good for wrangling data, really big data sets. Pandas is great for that. Matplotlib, that's kind of the most famous Python library for doing visualizations. And Seaborn is basically fancy Matplotlib, right? It has, the really cool ones. That's kind of what's going on. So these are just libraries that I want you to be familiar with the name. So that's another thing too, is like if you've done nothing with coding before, set reasonable expectations for yourself for how much you're going to pick up today. It won't be everything, but you're going to gain familiarity that you can then later probe further with ChatGPT. Because ChatGPT not only writes really good code, it's actually really good at explaining it too. And it will never run out of patience or time. So, I encourage you to stick with it. Just keep asking ChatGPT to keep explaining, keep explaining. Wait, what does this part mean? What does that mean? Keep at it. I really encourage you to. And I'll show you what I mean as we get into it a little more. Uh, yeah, yeah, that's the fire hose. Sorry, I just saw the comment. Okay, so let's keep going. So here's another example. This one is an example of a way to plot. So there's sort of two extremes in programming where you think of like, okay, there's object-oriented programming where everything's in an object and has these attributes and methods, etc. Another kind of way to think about programming, another kind of extreme way is everything is all about functions. Everything's getting passed from function to function. And there's some constraints on how those functions should be, like maybe only one output or, there's ways that functional programming has a bunch of rules. And interesting thing about Matplotlib is they tried to kind of make both parties happy with functional programming and object-oriented programming, and we try to make everybody happy, nobody's happy. So, Matplotlib, I gotta say, like personal preference. Maybe it's because I grew up with Mathematica. Mathematica is I prefer the syntax of Mathematica. But once you get the hang of Matplotlib, it works well. But I think part of the confusion is that some examples you see are kind of more functional based and some are more object based. So I have kind of two examples here just to sort of show you that. And again, don't worry if you're not catching every subtle thing for that. But the first thing you have to do, if I want to use Matplotlib, I have to import it, just like I imported cars earlier in the Mustang example, right? Um, let's see. So if I go import matplotlib, there we go. It's finished it for me, right? I hit tab. So if your Colab starts suggesting something and it's the thing you want, just hit the tab key. Uh, it saves you keystrokes and it saves you typos. So use that tab key. It's not lazy, it's smart. And then we go, so it's matplotlib.pyplot as PLT, right? And this is the way people always import it. So why do I say as PLT? That's like a nickname, right? I don't want to have to type out matplotlib.pyplot every time I want to use that library. I just want to type PLT. So that's why it's as that. And ChatGPT will always do it this way. It's never going to import pyplot in some cute way or whatever. And so once I have this object, this is an object, by the way, of course, right? So that's a matplotlib pyplot object. So that's the object I can call the plotting functions from. So for example, I can say plt dot figure tab. That function initializes a figure, and then I say plt dot plot. There we go. And I'm just going to give it some x values. Whoops. I'll give it some x values of 1, 2, 3. and some y values of 2, 4, 6. And in fact, you could even just run that. Let's see what that does. There it goes, right? So that actually runs fine. But we could be a little more careful and say like, well, let's do plot or plt dot label. Whoops, that's not what I wanted. Got to type it correctly. Plt dot, oh, whoops. That's why it's not working. X label. So this, of course, is the x-axis label, right? Which you probably guessed that. Even if you've never written Python before, you can guess what X label is. You can guess what Y label is, right? And then now we have an X down here, and then we have, let me zoom out a little bit as per, there's Y, right? There's Y as a function of X. So it's labeled. Another thing that's good to do, you see how there's like this little output here? If I want to get rid of that, you just go plt.show, and then you run that, right? So there you have it. I'm actually going to skip the object-oriented one just in the interest of time because we went a little too long on this, and I really want us to get into some examples. So let's see. Here's something good, right? If we want to be able to save this and do something with it later, I don't want you to be like screenshotting things, right? You might be able to just drag it. Let's just see if that works out of curiosity. Yeah, it does. So you can just drag it. That's probably the easiest thing of all, right? If you just kind of want to say like, this is on my computer now, right? I don't have to be on Google Colab to use this. I just dragged it to my desktop and it worked, right? So there it is. I'm going to delete that. So you can drag it. Kind of the smarter thing to do that gives you more control is to use this save function. So if I go like plt dot save fig, and it's going to be give it a name. And again, when we get the ChatGPT code, it's going to do all this for us. I just want you to see it done by hand, just so you have some idea of what goes into it. We'll call it plot.png, very original name. And we're going to set DPI equals 300, right? So I think that's dots per inch or something like that. It has to do with resolution. So if I run that, okay, it produced the plot. And now if I click over here on the files, look, I have plot.png, and now I can download that if I want. So now that's in my download. So that's another way to get it to my computer. But the reason this is better is because look at that resolution, right? That is a much higher resolution picture because I set that 300 DPI. When I just dragged it to the desktop, that's fine. Maybe you want to send your collaborator a quick update and like, here's what I'm doing, right? But it's not ready for a journal. This is ready for a journal now. Okay, I'm going to hit pause and take a look at the chat, see what's going on. Hopefully things haven't gone too far off the rails. Let's see. Thank you for the webinar today. You're very welcome. Thank you. I've been using Python, unfortunately. Oh, bummer. Okay, no problem. Thanks for saying hello. Okay, some people had to go. Yeah, there's all sorts of different ways to save your figure. It doesn't have to be as a PNG. Um, and that's something that, again, we'll be able to query ChatGPT for and see about that. So, okay, so let's keep moving through these example slides. So I just wanted you to kind of see a little bit of coding by hand. The rest of the session, after I do these last couple of slides, we're going to dive in as advertised and really get the AI to start doing a lot of the work for us. And then we're just going to make adjustments to it. But, it's easier to adjust something when you know what you're looking at. And so you see how like this objects just keep coming up, right? If I hadn't talked about objects, then you'd be like, why is there like a dot between everything? What is that? Now you know, like, okay, it's accessing something from an object, right? It's either accessing a method with parentheses or an attribute if there's no parentheses, right? Okay, so that is how to save a figure. So this is just kind of overview, right? So, you can generate and refine plots interactively. That's the goal today. When we get into the next session where we're going to be really doing things, working with some actual data sets, like, not just like one, two, three, four, five, six kind of data, like some real data sets. Basically, like, get ChatGPT to do a first draft of what you want your plot to be. Tell it as much as you think it needs to know, and read it and then run it and see how it goes. And if your plot doesn't look quite right, well, fix it. Ask ChatGPT to change something, or maybe you can change it yourself. example prompts. Like let's say it made a plot and you're like, oh, I wish the line was dashed. Okay, can you make the line dash? ChatGPT can do this. Can you add a legend to it? So that's an important thing is to know why I spent some time going over language. You'll pick up the language as you go, as you keep working with ChatGPT. Make sure that you're paying attention to like, am I learning the language? You have to learn the language. I don't mean like the programming language. I mean just like legend instead of key, right? Because sometimes you hear that called a key. But if you know that Python refers to it as a legend, now you're going to find things so much easier. So know the right keywords, or know that if the curly braces are there. So then you don't have to type like ChatGPT. There's something between curly braces. What's this thing about? So you could be like, hey, can you explain this dictionary? Why did you structure it that way? You know that it's called a dictionary. You know that the square brackets is a list. Just learn these basic vocabulary. You don't have to go crazy with it, but you definitely want to learn some of it. Or maybe that 300 DPI, right? It's definitely something with resolution. I think it's dots per square inch. I'm not even sure, but I know that it improves what do you call it? Resolution, right? Just ask ChatGPT. It'll tell you, and things like that, it's going to get it right. Python is one of the most readable programming languages ever, and data visualization problems are typically like the easiest errors to catch, right? If you're writing a code that does some kind of data analysis, it's doing some complex calculation, that can be tough to figure out where the bug is, right? If something's not running correctly. But if you're generating a plot, you probably know that like the points are too small or they're red and I want it blue or like things like that, right? So I think data visualization is a great place to start with, writing code using an AI to help you. So I think Python's the right language to do it, and I think data visualizations is the right place to start because they're easy to diagnose and they're easy to read. But I do want to caution you, do not, offload the entire cognitive load of creating your plot onto ChatGPT. When it gives you something to try, read it before you execute it. And then if it looks right, be like, oh, that worked. Oh my God, it really gave me, well, let me go see what it did, right? Because it probably used excellent syntax. Like it's a really good programmer. It really is. It writes good code. Um, to the point of like replacing people, I don't think I'd say that, but it's more that like you always want kind of responsible people who are, you have a person that you can ask and be like, hey, the code's doing something crazy. What happened, right? You're gonna want a person to explain what's happening and who actually understands what's going on. But if you're moving carefully, bit by bit, testing as you build, it can really help you build faster and more efficiently. And honestly, I feel my syntax in terms of coding things has improved because sometimes I'll ask for one thing, it'll give me a sample code, and while it fixed the thing I wanted it to fix, it also fixed some other stuff. I was like, oh, I think I've been coding that funny for years, right? So like pay attention to the syntax it uses. It's pretty good. So anyway, that's that. And by the way, this image was from Dali, right? This is the prompt. Please create a cartoonish ancient Spartan soldier experiencing brain rot from doing too much vibe coding. Include these colors predominantly. And notice I included the hex codes for the colors. So if you don't know about these, like that's another thing that ChatGPT can deal with very well if you give it hex codes, right? So those are numbers in base 16 for, you guessed it, red, green, and blue. So that's why there's 6 digits in total. And why are there letters and numbers? Well, it's sexagesimal, which means that we have 16 different characters. So at 9, we run out of a single place. So you switch over to letters. And so then we go all the way up to F. So that's what's going on with those colors. Okay. So let's see. I wanted to build in a little break just to kind of give everyone's like a little chance to kind of absorb things. Another thing I'm going to do, I want to make it so you can see my slides. So I'm gonna drag these into the shared thing. So if you want to kind of like take some time and like look at the slides I just showed you, please feel free. Let me just figure out where that tab went. There it is. Let's see. Data for participants. I'm going to give you access to my slides. There we go. There you go. There they are. So let's take kind of 10 minutes for let everyone's brain cool off a little bit. Feel free to, I'll try and keep an eye on the chat. I'll probably refill my water glass. But yeah, we'll resume in 10 minutes. I'll set a timer for 10 minutes. So I'll see you soon. Take some time to think about things. Ask some questions. I've got 4 amazing students here who can help you. So yeah, please stay active in the chat. All right. Thanks, everybody. See you in 10 minutes. Hey, folks, we still have a little over 5 minutes. I figured I'd come back a little early. Oh, let's see. Oh, cool. We got some questions. Let's start thinking about that. Cool, cool. That's awesome. Someone go that the you already know MATLAB so well. Yeah, with Matplotlib, I think the that's more the functional way. I think is more similar to MATLAB for using Matplotlib. In fact, I think some of the strategy in the creators of matplotlib.pyplot making the library, they were trying to steal MATLAB users. So they were trying to make it MATLAB friendly, but then also object oriented. And I think that's why they kind of hit that sort of in between where it's kind of like you can use it both ways. And some examples you see online will go one way or the other. I think the object way is actually the preferred way. You know, you do you, but the oh, the shared Google Drive. Let me put that link out again. Yeah, it's a public link, so anybody who has the link can access it. Let me just find the link. There it is. Share, copy link. Here's that link again. Let's see. What's a program oh, interesting. Okay, cool. Let's see how much time we have. I don't want to answer too many questions before we're officially back. But Michael, I think got Michael Goldman. I think C is considered more of a functional language, whereas C++, then you have structs, right? You have those objects that you can have in C++. So I think that's kind of one of the big differences between C versus C++. Um, yeah, I used to do a lot of C and C++ as a PhD student, and I have a project now. There's a combination of R and C because we're writing our own library in R. So then libraries are typically written in a combination of C and R. So we're doing some C for things that have to be fast, and then R for the other stuff. There we go, Fortran. Love it. Fortran is still alive and well in a lot of physics and physical chemistry circles for certain things. Certainly. I mean, it was good enough to put a man on the moon, right? That's right. No knocking Fortran. That's right. That's awesome. Yeah, I mean, for doing math, right? Formula translation. It's there's a reason it's got staying power like that. I don't think anybody else can touch Fortran in terms of staying power. It's really I don't think it's going anywhere. Good for them. Let's see. Some of the molecular dynamics software that I've run, it has Fortran's doing stuff. It's like, it's in the back end. It's in there. I've written a tiny bit of Fortran a long time ago, but I certainly wouldn't say I have any kind of proficiency in it, but I've dabbled a little bit. That's awesome. Let's say we have about a minute and a half left before the end of our break. I always do this when I teach my programming, my Python course for chemists as well, as I think it's kind of good to give your brain time for things to settle in. Let's see. So any concepts to return to? Oh, and I just saw Masaki asked, is this webinar recorded? Yes. Yeah, this will eventually go on the YouTube channel for CSU Biotech. Oh, something I forgot to mention. I should have. This is why people don't introduce themselves. I forgot to mention. So I'm doing today's webinar for two different efforts. One is for the CSU Biotech organization. So this is across all the CSU campuses for folks who are involved in biotechnology research of all different types. I'm representing that, and then also the AI Faculty Fellows Program at San Jose State University. So we have different faculty fellows from one from each college. So I'm representing the College of Science. So I should have mentioned that, and I totally forgot. All right, I think my alarm's going off in 15 seconds. Close enough. All right, let's get back into it. So let's see. Okay, before we, really get back into it, are there any questions that I can answer? Just type them in the chat. I'll give that like a few seconds. I'll give it the remaining 10 seconds. Okay. Go ahead and share my screen again now. Let's see here. Okay, so I'm going to share my screen again. If I can find the button, there it is. Share. Okay. All right, we're done with the slides. We can close that. Now let's get into some of this data here. So here is the data for participants. Here it is. So this is all the data that I've shared with everyone. And so the first thing I'd recommend you do is download the one that we're working with onto your computer so that you have it locally. So I would download. Let's do ethanol first. So this is the easier one to do. So click on this one, click on download. And now this should be in our downloads folder. Where'd it go? There's my downloads. Oh, that's right, the chat. There we go, put that over there. So here's the downloads. Let's see. I'll just drag this here for now. And I'm going to get rid of that one there. By the way, programming thing, don't put spaces in your file names. It didn't used to be allowed, and then they keep trying to make computers easier and easier to use, so then they end up having to like twist themselves into circles to try and accommodate things that people want to do, but they just not do it. Never put spaces in your file names. Trust me on that one, especially if you're going to be dealing with Python and things like that. So okay, so there's our ethanol data, and let's get ChatGPT fired up here. So one of the things I did to prepare here, so I'd been trying some things out, right? I didn't want to go in here totally cold. This is this is a real live demonstration, right? So things could go off the rails, but obviously I did practice some things ahead of time. So one of the things that I did is as I finished up kind of practicing things, I tried a whole bunch of different stuff here. But towards the end, I said, you know what? I'm going to be using ChatGPT in the middle of this session. Can you write me a prompt that I can start a new conversation on ChatGPT with so that it's already prompted to talk about the things that we've talked about, right? So all the different bugs I ran into as I was developing the different approaches and stuff that we'd be using today, they all came up and so that created a prompt for me. And then I just pasted that into a new conversation. So here's the prompt that ChatGPT wrote that I then passed back into ChatGPT, right? You're assisting me, Dr. Gianmarc Grazioli. I'm a professor of computational chemistry leading a hands-on workshop on Python data visualization, etc. Right? I'm not going to read that whole thing to you, but this was a prompt. So it already has a bunch of information about what we're working on today. So the first thing I'm going to do, I'm actually just going to drag this CSV file right here. Obviously, don't put any data into ChatGPT that you want to keep private. Right? If there's student data or something sensitive, do not put that in ChatGPT because then it's going to their servers. They're doing who knows what. So anyway, but obviously I'm fine with doing that with this data. So if I drag this in here and I'm going to give it a prompt, I'm going to say, here is a CSV file for an NMR spectrum. I would like you to please create a downloadable Jupyter notebook. So I'm going to call it a Jupyter notebook because I want a downloadable file. Whereas Google Colab, again, this is like the difference between like Microsoft Word doc and what do you call it? Google Doc that just kind of lives on the cloud. So that's why I'm asking for a Jupyter notebook. So again, keywords to know. Create a downloadable Jupyter notebook that creates a nice looking plot of this spectrum. Um, let's see. I'm going to kind of tell it something you might not think to say, but I would like you to first load the data into a pandas data frame, then do the plotting. Okay. So there's different ways of getting your data into, from a file and into the Python session. I want it to use pandas, right? Because it's really good for loading data like this from CSV files. So by the way, highly recommend whatever data you work with. You have a lab. Let's say you're collecting your data in Microsoft Excel sheets. That's totally obviously great. It's really good for data collection. But in the end, export it as a CSV file, load it as a CSV file. Although Jupyter Notebooks, there are libraries for accommodating Excel files. Don't bother with it. It just get your data into a nice looking CSV and then get your data into Python. Because it's just going to add a layer of like annoyance and overhead of dealing with Excel that just doesn't need to be there. So cut Excel out of the mix. Um, my students are probably laughing because I'm always talking smack about Excel. It's fine for small data sets, right? But if you're really going to have some big data sets, like you gotta, I don't know. I won't get into Excel bashing. Okay, so we have our CSV file. I said use a pandas data frame because I really want you to see that, and I think you'll see why. So I submit this. So I asked for a downloadable Jupyter notebook. It creates a nice plot of the spectrum. I said load it into pandas data frame first and then do some plotting. Okay, great. So interestingly, you can even run it in here. I'm not going to do that. Well, why not? I'm going to click it. Is it done? Yeah, it's done. Let's see what happens if we click run code. I don't usually do this, but why not? Oh, forget it. Get rid of that. So I'm just gonna do it like I always do it. I'm gonna copy the code. So if I click copy, wait, where's the downloadable Jupyter notebook? Oh, yeah. Would you like me to add a downloadable link for this notebook? Let's see. Yes, please. This is what it doesn't always do what you ask it to do. Yes, please create. Well, you know what? We don't have to. Let's make our own. Let's do that. Let's do it ourselves. So if I'll do it. Actually, I'll do it in the data for participants here. Oh no, I shouldn't do it there because then people can accidentally modify it. I'll make my own here. So let's do in session scratch. Yeah, we could do it in here. We'll do it in the scratch one. That's fine. Because I'm not going to import anything to. Well, no. Let's make a new one. Uh, more Google Collaboratory, and we'll call this one in session NMR. Double click in session NMR. And notice anytime I want a space, I'm using an underscore, right? Don't put spaces in your file names. It's a bad habit. It causes problems that don't make problems for yourself, right? That's what it is. Okay. So let's copy, let's copy this, copy that, and then I'm just going to paste it all into one cell. Paste. There we go. But obviously it doesn't have the file here. So make sure the CSV file is uploaded into the environment. Okay, so that's easy to do. Oh, look, it even told us how. Manual is using the left side folder icon. Yep, that's correct. So here's the folder icon. If you click on that, any files that you want your Jupyter notebook to have access to, just drag them there. So here's my ethanol spectrum. I drag it there. It's going to warn me like, hey, I'm not saving this. That's fine. I have it on my computer. You don't have to save it. Right. So once I close this session, it's not going to have that file anymore. So every time you do the plot, you will have to drag that in there. But it's a pretty small price to pay for something that's so portable otherwise. Okay. So let's read this a little bit and then let's run it and see what happens. Maybe it makes an error, maybe it makes a plot. So step one, we're loading our libraries. So ChatGPT told us these are the libraries we're going to need. Good, it used pandas. I wanted it to do that. Matplotlib, and then NumPy, right? That's numerical Python operations, right? So I've talked about all these, and that's why I wanted you to be familiar with that. Be like, okay, these are libraries. This is functionality. It's bringing into my session. Step two is loading. Okay, so here it's loading it. The file name equals a string, right? If you see things in quotes, it's a string. So our file name is just a string. It doesn't have to go looking for it in any sort of file path because I just dragged it right here, right? So Jupyter by default, or Colab, Google Colab by default is going to look here for any files. So I put it there. It's there. It can read it. It's going to call it a data frame. It's going to say pd.readcsv. Okay, PD is the nickname we gave pandas. Right? That's just the nickname for the library. And then this library that I've loaded into this object PD, it has a method called readcsv, right? I'm pretty sure we know what readcsv does. Um, let's see. Thanks a lot, Joel. Appreciate you helping out. And good luck. Let's see. What else do we have? Okay, then we have display df.head. So I'll tell you, oh, it tells you what it's doing. It displays the first few rows to verify the structure. So I'll run this and we'll see. Actually, you know what? Let's do this step by step. I'm going to copy from here down. Let me zoom out a little. I'm going to copy from here down yeah, I'll copy from here down. And I'm going to cut this out and put it in later. There we go. Command X to cut. If I click over here in the white part and I type B, it creates a new cell below, right? So you can add this you can click the little plus sign up here. This is so much faster, right? If you're going to be doing a lot of this, you want to learn all these little shortcuts. So, if I'm clicked in this cell and then I click out here, I just type the letter B, bang, below, I get a new cell. So good trick to know. A puts a cell above. So good trick to know. Okay, where were we? Yeah, I split this up because I want to run it in chunks here. So let's see here. So this is just loading the library and then loading the file. I think that's a good thing. Let's just run this by itself. So shift, hold down shift, press enter, and that's going to load. So now we've loaded everything. And now if I click here below, whoops. There we go. So now if I'm here, if I want to just take a peek at this file and I go df.head, head is a method built into any data frame. Just think of it as like you have your data and you kind of peek your head out, right? That's kind of what it's like. Um, let's see. There's an issue with it that I'm going to choose to ignore for now. We're going to keep going. But notice that like, you see how these in bold up here? Those are like the titles for my columns. The title of the one is 7 and the other one's 0. Do you think maybe it's taking my data and treating it like a column title? That's what's happening. It's easy to fix, but um, anyway. So now if we go to the next cell, we've loaded the data. We have print the head. I showed you printing the head. So that's just going to show us the data. I wanted to show you that separately just so you see it. It's going to tell us print column names. Do you have columns to list? All right, it's going to print some stuff out. Here it's doing the plot, right? So notice it's calling PLT, right? So here's where the actual plotting starts. Um, I mentioned that like there's like the object way and the functional way of doing matplotlib. This is using the object way, where you have the figure and then the axes becomes like an object. But anyway, let's run it. Let's see what happens. Shift enter and uh-oh, what's the error? Chemical shift. It doesn't know what chemical shift is. Ooh, okay. So let's take a look at the code. So did ChatGPT make a mistake? You bet it did. I know how to fix it though. So if you look at the data frame, and actually, you know what? I know how to fix it, but let's make ChatGPT fix it. So when you get an error like this, it'll kind of show you the cascade of like all the places where it's making it, where the error is causing problems. A lot of times the stuff at the bottom is kind of the most useful. But you know what? Let's say I have no idea about that, and I'm just going to copy. I'm going to copy this whole error. So I'm just going to copy this entire thing and let's give that back to ChatGPT. So we see key error chemical shift. So I told you about dictionaries that have keys and values. So you think, okay, probably has something to do with the dictionary or maybe a pandas data frame because they behave a lot like dictionaries. But let's just paste that whole thing in there and just say, I got this error. I'm mad, right? I got this error. Just tell it that. Let's see what it does. Very common. Your file doesn't have a column literally called chemical shift. So remember when I pointed out the columns, it was calling the one column 7 and the other one 0.0. So that's what happened. Oh, interesting. Okay, so it's trying to pivot, all right, to list dot head. Oh, that's funny. So it looks like it's trying to switch things up. All it has to do is rename the columns. So columns in your CSV. Let's see here. Intensity. There's intensity and ppm. So here they're naming the columns for the plot. I see. Let's see. So what it's doing, it's fixing the plot, but not the data frame. So remember I told it, like, I want you to do this with a data frame. And it's not doing anything to fix the data frame. So I'm going to say, like, it seems you're addressing the plot, but not the data frame not having column names, also known as a header, i.e. a header. Can we just add column names? Let's see what it says. Excellent catch. Yes, that's exactly right. Your CSV file has no header row, blah, blah, blah. So therefore, it can't access chemical shift, right? So this is what I told you it was what the issue was is interesting. Like when part of this might actually be that when I was developing my practice run, I called the column chemical shift. Granted, it's kind of a obvious thing to name the column. I called it chemical shift and intensity. So maybe that was stored in its memory. So maybe this wouldn't have happened to you. And maybe it only happened to me because I had previously done that. And, ChatGPT does keep track of your conversations. So maybe that's part of it. I don't know. But if we just do header equals none, right? Header equals none tells pandas that the CSV file has no header, and then you can name it. You can name your own header. So this is how we want to do it. So let's fix it that way. Here we go. So if we change this line, df equals pd.read CSV, header equals none, and then names equals that. So let's swap that in. So where it says df equals, back when we read it in here, right? We're going to get rid of that and we're going to put this one in there. Now, when you modify code, don't delete things willy-nilly because you might want to bring it back. So a good habit, if you put a hashtag or a pound, it turns your code into a comment. So this no longer executes as code because I put that pound there. So I can turn that off and I can put this one there. So before I was reading this into the variable df, now I'm reading this into the variable df. And let's see if that fixes it. If I do that, I run the head. Okay, now look, chemical shift intensity. Now we have names, right? We don't want to have no names. Now let's see if it fixed the plot. Hey, look at that. That's a nice looking plot. There we go. So that was the issue. Let me check on the chat. I believe I saw a question come up. Okay. Can we assume the code my chat GPT generated is identical to one you are showing? No, don't assume that. There's some randomness in ChatGPT for sure. Sometimes they call it temperature, which I think actually kind of comes from molecular simulations where if things are getting kicked around randomly, that's like things being hotter. But let's see here. Are you going to be sharing the ChatGPT prompts you wrote today and the code it generated? Yeah, I can do that. I can do that. Yeah, if I forget, please send me a reminder, someone. Appreciate it. But yeah, don't assume it's the same, Ray, but great question. So I fixed that one thing and now it works. And that's a pretty nice looking spectrum if I'm being honest. Right? So saves are kind of already there, right? But then let's take a moment to look at this and see what it's doing. Okay, displayed the head. That has nothing to do with the plot, but it's a good idea to take a peek at what your data looks like. So anytime you load your data into a pandas data frame, right? I highly recommend you work with CSV files. So however you collect your data, it's probably something involving Excel. Export it as a CSV. So, you also like you don't want to go crazy with like doing special formatting in Excel because that's not going to translate well to a CSV. The closer you can keep your data to just being like a pure grid, the better. You just make your life easier. So if you kind of, like think a step ahead and say like, all right, ultimately I want to do my data visualizations using Python. Well, that means ultimately I want to load CSVs. Well, that means I should set up my Excel file so that it outputs a nice looking CSV file with no issues. Whereas, if you're doing all kinds of, wild things with Excel, like, you can make Excel worksheets look pretty cool, but I advise don't do that. Keep it simple instead. Um, Hey, keep it Spartan. There we go, right? San Jose State representing. Okay. So so here's our chemical shift. It goes up to 7, down to 0. There's a lot of stuff we could do with this. Let me check the time. Yeah, let's play around with this a little bit. So here we have an NMR spectrum. One of the things that's commonly done with an NMR spectrum is you want to take the integral under a particular curve to see how many hydrogens are producing that signal. So this is a proton spectrum of ethanol. Um, so the area under these different, like this is called a quartet, this is a triplet, that's a singlet. The area underneath each one is going to be proportional to how many hydrogens are causing that signal. Um, let's ask ChatGPT. I think this could be a cool thing to do. Let's say I want to integrate the area under the quartet. So let's see. I'm not going to assume it knows where a quartet is, right? Because looking at the image, fine, that's obvious. But it's looking at it had a bunch of numbers in a CSV file. So instead, I'm going to tell it a range in the x-axis. So I'll say from like, let's say like 3 point, I'm just going to guess, 3.25 up to 4 is the quartet, right? So I'm going to write a prompt to ChatGPT now. I'm going to say, I'd like to integrate. Actually, let's integrate the whole thing. I'd like to do a numerical integration over this entire spectrum. Please write a code that will take the full numerical integral using the pandas data frame as input. See what it comes up with. Since your spectrum is in a pandas data frame, we can use the trapezoidal rule. Okay. So if you're not familiar with numerical integration, if you have some curvy thing like this, right, that's not like an obvious function that has like a analytical integral that you can look up or whatever. Um, Imagine you pack a bunch of trapezoids under there. You know how to, the area of a trapezoid is a known thing, right? Or even more simple, there's the rectangle. You can even just put rectangles in there, right? Length times width. Add up the area of a bunch of rectangles, and that's going to get you pretty close to the value. So in this case, they're recommending the trapezoid rule. That's fine. NumPy, that library came up again, has something called traps that'll do this. So let's see. So first, let's take an integral of the entire thing. And it looks like, I don't know why they sorted it. Sort by chemical shift ascending. Well, that's fine. So it sorted it, and then it took the integral using traps. So let's check this out. I want to copy that and run that. So it's creating a new data frame called df sorted, right? Where it's going to sort the values by chemical shift ascending, right? Again, this is one of those things where like if I asked you to write the data the pandas sorting function to sort a data frame, you'd look at me like I don't code. What are you talking about, right? Or I'm just getting started. But if I told you to read this and say like, what do you think it's doing? okay, it's taking a data frame, sorting the values, it's sorting it by the chemical shift, and ascending equals true. Okay, so it is ascending. It's going in ascending order. But that's so readable, right? This is kind of what the point I'm trying to make here is that like to know that this is the syntax to do that, that's not obvious. When given the syntax by a large language model and you have it, and you're looking at it, that's pretty obvious what it's doing, right? What else could that possibly be doing? So that's going to be DF sorted. So first it's creating a new data frame where the values are sorted. Um, then it's going to run the trapezoid rule on it, and it's sorting it by chemical shift. So it's sorting it by the x-axis values. Um, and let's see. So it's sorted by the okay. And now this. Okay. So now what's happening here? This is maybe a little less obvious, but I'm going to show you how to dissect code when you're not sure what it's doing. This is another good skill to have. So I say, okay, np.traps. Okay, I know that this is NumPy calling the trapezoid integration function, right? You could probably guess that, and the AI told us that, ChatGPT told us that. But then, like, why is it going df sorted and then square brackets intensity? So what's that doing? So I know what it's doing, but if I didn't know what it was doing, what I would do is I would copy this, paste it in its own cell, and just run that part and see what it shows me. Oh, hang on. Okay, first I have to run this cell. Actually, this is a good reminder. So I pasted this in the cell, but I did not hit Shift Entered yet. I didn't run that cell. So just because you type this, the interpreter doesn't know what that is until you execute it. So it's good that I forgot to do that. So if I go Shift Enter, there we go, that ran. So now that that ran, now it knows what DF sorted is. So now I can take this part that I wasn't sure what it was doing right here, and I can execute it in its own cell and just see what it gives me. Okay, so there we go. All right. So if DF sorted, I put in square brackets the name of the column intensity, it's just returning the intensities. Because if I'm doing the integral, I'm integrating over the dependent variable here, right? Or I'm integrating over f of x, right? Um, so for this traps library, you have to give it your y values and your x values, right? And so the x values are chemical shift. So here we've selected the chemical shift. Here we've sorted the intensity, or we've selected rather. So, right, that one selects only the chemical shift values. So that's what's going on with this is these are my x, it's this is pulling out only the x values, this is pulling out only the y values, because that is what the traps function is expecting, right? NumPy.traps is expecting y as a function of x, right? And ChatGPT wrote that whole thing. So if I type out area here, what's my area? Yeah, it's basically 6, right? So that's correct. I created this example. I can tell you that is the correct answer. So it did do the right thing here. So this is how you can, do some analysis even that maybe maybe would have been a little more difficult without ChatGPT there for you. So let's see. Oh, I just saw a question in the chat. Let me see here. Could you please repeat the GPT prompt? I'm guessing it's probably the last one I asked. So I said, I'd like to do a numerical integration over this entire spectrum. Please write a code that will take the full numerical integral using the pandas data frame as input. Yeah. So basically I was saying like, tell me how do I do a numerical integral here? And it showed me how to do it using a NumPy function. So, so that's that. Another thing that you might want to know how to do if you're doing a plot would be, let's say, okay, the size of the figure might be something you care about. Let's just double these numbers. Let's make it 16. And so this is why, it gives you the code, but like read it, see what it's telling you, see what it's doing. Fig size, that's probably figure size, right? So if I double this, 16 and 8, now my figure is twice as big, right? So, you know, there's all sorts of things that like, once you kind of have what you like, um, you can figure out, or so, once it gives you some version of it, you'll automatically know what you like or don't like about that figure, right? And then things to change. And if you didn't know, let's say I didn't know, um, the figure is too small. What line do I change for a larger figure? Thinking about it. Excellent question. I don't know if it was that great of a question. Here we go. And then it points out this line. It says that's the one. This is width. This is height. All right. So it's not just about asking for code. Ask it to explain the code. It's really good at doing this. Here we go. Now it's talking about saving it. For live teaching or high-res exports, these sizes are good. You can also combine this with plt.savefig, a large one DPI for publication quality export. So that's the one where we set DPI to 300, right? We really pack those points in to make it really high resolution. Um, but maybe, does the size and resolution go together? i.e., is bigger automatically higher resolution? They're related but independent. So fig size is going to set your physical dimensions. Resolution, the DPI, that's the pixels, right? That's the number of pixels that are packed in there. Yeah. So anyway, that's some things we can do with the NMR spectrum. Are there any questions about the NMR spectrum? Honestly, it did a pretty good job right out of the gate. I wouldn't get rid of this grid. I think the grid's kind of unnecessary. Let's do that. Let's tell it there is a dotted line grid in the background that I don't like. How do I get rid of it? Good eye, the dotted background comes from the line this. Okay, so this is Seaborn, right? This is like the fancy stuff. This is one of the so it's using a style. So matplotlib.pyplot, which we've loaded using the nickname PLT, right? This is just our plotting library object, has something in it called style. And so there's different styles you could use, and then say dot use, and you give it the one that you want to use. And I'm sure ChatGPT knows a bunch of different styles you could use. So this automatically adds light grid tones. You can have a few clean ways to remove it. I could just do ax.grid equals false, and it says right after plotting, add that. Okay, so let's find the line where the plot is made, and let's add that. Let's see. There it is. That's the line where the plot happens, right? Where'd it go? ax.plot. This is it. So right after that, enter, paste. That's still there. That didn't work. You gotta have a sense of humor about this. It doesn't always do what you want it to. Wait, did I put it in the right place? Yeah, I did. Didn't work. Ax.grid, false. How about that? I'm gonna tell it. If you prefer to remove the, yeah, I think it's really the seaborn. Let's put default in there because the seaborn thing really lends the grid there. So I think we're kind of giving like competing commands here. So I'm going to get rid of that. Let's just not do Seaborn. Where's Seaborn? There it is. This thing. Optional. Apply a style for a polished look. What if I just comment this out? Let's just turn this off. Again, I'm not going to delete it because what if I decide I missed the dotted lines later, right? I might want to bring it back. So I just turn that into a comment, run it. It's still there. What happened? Seaborn. That's weird. Did I do it in the wrong cell? See. Nope, that's the only place Seaborn shows up. Fascinating. I'm going to try running from the beginning again. I don't think there's something in a different cell. No, it's not that. Weird. Huh. Oh, here we go. Ax.grid. Again, read the code, right? I should have read that a little more carefully. Ax.grid. Let's try and get rid of that. I'm going to turn that one off now. Run that. Okay, that made it dotted, right? You see the change. It went from dotted to solid. Let's see. Ax.grid. Ax. Fascinating. Line style. Oh, why don't I just set it to false? Here's a true. Let's try making it false. Nah, interesting. All right, I don't want to spend too much time playing with these grid, but this is something we can get rid of. If we were stubborn, we could absolutely get rid of it. But there's another example I kind of want to get to. Oh, what? Someone found something. There was a grid true line several lines below that. Oh, let's find that. Grid true, huh? Grid false. Oh, I think that. Oh, wait. Oh, no, that's the one we tried already. Okay. Yeah, you must have posted that before I said that, I think. Okay, got it. Got it. Thank you anyway. Well, we can fight with that later if we want. Um, let's see, DF dot plot, color navy. It's funny, stuff like this. I have a hard time just being like, all right, moving on. It's bothering me. Let's get rid of the tick params. Let's just keep turning stuff off. Let's get rid of ax.tick params, right? So I'm showing you like play around with it, right? Well, anyway, all right, I'm done. We'll move on to a different one. Are there any questions about the NMR? Let me try one more prompt because this is going to drive me nuts. Give me a super basic plotting command. Everything seems to include. I want to try one more thing. So this is a good time to talk about the this runtime thing. So there's something called the kernel. Basically, like as the Python interpreter is running, we call it like the kernel. That you can sort of restart it and basically say, all right, forget everything I told you, right? So I'm going to look for something that says restart and run all. So restart session and run all. I just want to see if there's something hanging around. I don't think this is the case. I think the grid's still going to be there, but I just want to rule this out because it's funny the amount of things I've turned. Oh, there, it's gone. That did fix it. How about that? I'm glad I tried it. So, sometimes things like this happen. I think something must have gotten loaded that even though I kept rerunning this, it must have like maybe the style remained loaded, something like that. How did I know this would work? I didn't know it would work. It was a hunch. I thought I'd give it a shot. So keep that in your bag of tricks too, right? It's usually not that, but it can be. Maybe there was something that was defined somewhere earlier and I didn't rerun it later. Who knows? But somehow I told it to forget about Seaborn and it finally did when I restarted the kernel. So that's another trick for you. Good. Now I can move on with life knowing that we solved this. Okay. So we have anything else in the chat? Oh, interesting. So Ray says my Colab interface automatically shows an AI chat terminal. Did a good job fixing some syntax errors. Wouldn't you recommend using this bot versus ChatGPT? What's the difference? Yeah, so the whole like AI everywhere thing, right? It really is showing up, in the darndest places, right? But yeah, you can enable like an AI assistant in your collab sessions. You can put it all sorts of places. Honestly, I like to keep it contained. I like to just have it in ChatGPT. I play well with Perplexity sometimes. I keep going back to ChatGPT. It just works for me. But I don't really like the built-in AI assistants as much because I think it's just a little too heavy-handed for me. Like I want to choose like when I want to use it or not. Um, like I wouldn't do a smart house either. Like I don't like when it's everywhere. I like to be able to kind of like I determine when I'm going to involve the AI or not. So I would actually recommend against using that, but that's my personal taste. You do what you want to do. But it was a good question. Let's see here. Alan says, I believe Colab AI will autofill or debug really quickly within the specific cell. Well, ChatGPT will give you a more detailed explanation of things. Yeah, good answer, Alan. And thanks for answering. Alan's one of my amazing students. Good job. Thanks. Spectrum already didn't have the grids when you were trying to remove. Oh, interesting. Yeah, yeah, exactly. So that was a weird thing that the grid was hanging out. But my suspicion was right that something got loaded that was like it was just hanging out. So even though I kept turning off more and more of these lines, uh, and by the way, notice how little of this you actually needed just to make a decent plot. Okay, it's no longer saving. Let's turn this line back on. Oh, I see that they actually gave it to us commented out, right? So when it gave us the code, it said, well, I don't know if you want to save it or not, but if you do, turn this on. Okay, so all we have to do, turn that back into a code, turn it from comment back to code. And now this is going to save this. So now if I run that, keep an eye on this part over here. There it is. You see it? It popped up. Where'd it go? Ethanol. So now if I download this, download, and now where'd it go? Now I have this beautiful plot that lives on my computer, right? This is really good resolution too, right? If I zoom in, that's pretty darn good, right? That's that. And if that's not enough, just up that DPI, make it 600, right? Go crazy. Um, so yeah, so that's example of doing that plot. I have another example that I think could be fun to play with too. I was actually hoping to get to so somebody kindly shared some data with me to use because I wanted to work with some of your data. So that individual, please feel free to reach out to me via email. Like we'll just set up a meeting sometime, and I'd love to work with you. It looks fun to play with. But I have one other that I think is kind of a little easier and more generalizable that I want to focus on that example, just in the interest of time. My background slides took more time than I thought they would, but I think it was time well spent. Because again, you want to get the lingo down before you get too deep into using uh, ChatGPT to write code for you. Okay, so let's work with a different data set. So I have another one called Bradley Melting Point. So I'm going to just download this now, and let's do in session. I'll make another one more Google Collaboratory, and we'll do melting point analysis, something like that. The melting point analysis. And I just downloaded that data that I want to use, this Bradley melting point curated data. Let me just open this real quick. I'll open it with Excel just to take a peek at it and show you real quick. Don't convert. I want it to be a CSV file. All right, so here's the CSV file. So, this is pretty long. This actually came from a larger data set. Let me share it with you real quick, actually. If you want to practice on data sets, there is an organization called Kaggle. I highly recommend you sign up, create an account on here, and there's so many data sets you can find. Basically, sometimes what happens is like a company will have some data set that's kind of like a one-off project. And rather than like hiring someone to do some analysis for them as a data scientist, they'll make a contest out of it. And they'll say like, oh, I have this melting point from chemical data, right? So I have all this different data about the molecules. There's all kinds of things like, how branched is it? How many polar groups are there? How non-polar is it? What's its molecular weight? There's so many different descriptors for the molecules. And they put this information out and they say, train a machine learning model that will predict its melting point based on these inputs. And they have a contest and people will just kind of do their best and compete for a cash prize. So then, whoever wins gets money. The company gets like free, not free, for the cost of whatever money they put up for the prize. Um, they get work done for them. So anyway, there's a ton of great data sets on here. Another great one. So I'm a UC Irvine alum for my PhD and postdoc, and they have some really great data sets as well. So if you just look up like UCI data sets ML, that should get it. Yeah, there it is. UCI machine learning repository. All right. This is actually kind of the most famous one for learning machine learning. So there's lots of great data sets out there. I want you to know about this. I just want to show you that real quick. So that's where I got this melting point data from, is from there. Um, but this is what it looks like if I open it up in Excel, right? It's 4,000 rows, but it was actually like, I think about 30,000 rows, but I made this smaller version just for testing here. And you have access to this as well. It's in that shared directory. So if I click on the folder icon and I drag this over there, is it loading? Oh, wait. Connecting to a runtime to enable file browsing. Yeah, good. Oh, let me close this one. I think I have too many of these things open again. Let's close that file, save, and I'll just close it. There we go. I think it's going to work now. Yep. It just showed sample data. It was getting a little laggy on me. I think because I had more than one open. And so, Google's being smart about this. They're not Um, they don't want you to go having too many of these things open. So I drag that over there just like before. Warning, it's going to tell us that warning. Hey, I'm not saving this. Fine. There it is. So I don't even think we don't need the AI to tell us this. Let's import pandas as PD, right? We already know about doing that. And then let's do PD dot, let's go, I'll go df equals PD dot read C, what was it? Read dot underscore CSV. I give it the file name, which was copy path. It puts this content in front of it, but you actually don't need it. There we go. So now df.head, I'm just doing stuff that like, we've talked about doing just to kind of show you. So this is what the data set looks like. We have a key, a name, smiles. So if you're not familiar with smiles, this is a way of representing organic molecules using just plain old text. Uh, Super useful thing. Um, Very important in the field of cheminformatics, where you want to like, store chemical information in ways that make sense for computers, right? Because the way people store chemical information, express chemical information, is often quite different from a way that it makes sense to do it on a computer. And then this is the melting point in Celsius, MPC, and then all kinds of other information. But so this is the data set that I've shared with you. But again, we're going to go to ChatGPT. So I just wanted to take a peek at it using functions that we've discussed. But let's try another one now. So this was this. Okay. Now I have melting point data. Melting point data from, you know what? Let's give it the website too. We got it from here. Nope. I think you can access that here. I want to, let's see. Let's look at a matrix of correlations. I want to produce a correlation matrix to just kind of see like we have all these different things. Are some of them correlated? Are they anti-correlated? Or not correlated at all? I want to produce a correlation matrix and also do a linear regression with a plot. Please help. Here is the file. And then we give it the file, give it that CSV file. There it is. And it's loading. Alrighty. You can copy and run the entire block below in Colab. Alrighty. Explanation for students tells you about correlation matrix, linear regression, R squared. Yeah, let's copy this thing. Let's copy the code. We're gonna paste it here. All right, it's reading stuff in for DF here. So let's go ahead and just delete the one that I did, right? I just wanted to show you a little peek before we work with their code. Because I think that's probably a good thing for you to remember to do, just to take a look at what your data looks like. So if we look at this, what's it doing? It's importing pandas, it's importing NumPy, Matplotlib, right? Those big three. Seaborn, okay, it wants to do some fancy plots, right? So when you see Seaborn, think, okay, fancy plots, cool. sklearn, if you see sklearn, I think that's machine learning library, and it's importing from that linear regression. Okay, I said I wanted to do linear regression. That's why that's there, and also this R2 score, it's bringing that in as well from sklearn. Now you can import like an entire library, sklearn, or if you're only going to use one small part of it, you can say from sklearn import that, right? Because the only thing I'm using there is from linear regression. It goes back to the example I gave you, like Microsoft Word takes so long to open because it's loading all this functionality you're not going to use, right? We don't do that here. This is Python. We work smarter. We bring in what we need. So there's that. It gives the file name. That's just this, right? It reads in a CSV file. Great. This time, I don't know if you noticed when I showed the head, it does have a header. It does have column names, so we're okay to not have header equals false this time or none. Let's see. It's gonna show us a preview again. So it's gonna show us the head. What else is it gonna do? It's gonna do a correlate. It's gonna select certain data types. Okay, so it's going to pull in, okay, it's going to pull in the numeric values here by selecting certain data types. So select D types, select data types. That's what that means. And this sort of stuff, like, if I didn't know what that meant, again, you can always ask. Be like, what does this mean? That line is subtle but very useful. Uh, Give me only the columns from the data frame that contain numeric data. Okay, great. Very straightforward. Um, Let's go, in the interest of time, let's just go ahead and run this thing. Let's see how it does. Neat. All right. So this one, so let's see what it did. So it looks like it worked. Let's see. Oh, we do have an error, don't we? None in the columns. Interesting. Okay, so we did get an error. It did produce a correlation matrix, which is cool. So notice we're seeing so if it's one, it's perfectly correlated. If it's -1, it's perfectly anti-correlated. So we're seeing ones down the diagonal, so that's good. That's a good sanity check that things are correlating perfectly with themselves. Let's see what else is going on with this. It's funny how things go with demos. I got no errors when I ran this earlier. By the way, this ties into one of the questions. Like, do you get the same thing every time? No, definitely not. Let's see what it, okay, so it produced an error. You know what? Since we're running out of time, let's just copy the error. So you don't want to slip too far into vibe coding. So if you're not familiar with the term vibe coding, it means you just ask for code, you run the code. If it gives an error, you just copy the error, paste it back, and you don't read anything. Just keep running it, telling it what's wrong. That's vibe coding. So we're kind of slipping into that just because we're down to our last 10 minutes, and I really want to get this thing fixed before we go. But let's see what's wrong. Perfect. That's very common. Okay. Your data frame does not actually contain columns, molecular weight, and melting point. Okay, so it's using names. Don't ask me where I got them, right? We gave it the CSV file. So for some reason, it's looking for names that aren't there. Okay, so for now, I'll just say, please correct the entire code block so that it works without error. Fully working. We'll see if it gets it right the second time. So again, normally I would spend more time reading this, but let's just see if it works. Copy that, select all, delete, paste, shift enter. Still an error. That's funny. None of are in the columns. So it's still looking for names that are not there. Not sure why that is. Did I drag a different data set in? I don't think I did. Column name mismatches. Clean and lowercase, no key errors. Well, let's give it the error again. Why not? Wouldn't you know? That's how this always goes, right? Let's try one more. Just gonna paste the error in and see how it responds. So this is a little bit refreshing to see that this thing still makes mistakes. Right? Perfect. This tells us your CSV uses slightly different. Okay, fine. We'll use the ones that are in there. I gave you the CSV. It says this one's gonna work. We'll try it again. See if it got right on the third try. Is third time a charm? No, it's not. Wow. Okay, so this is really interesting. It usually doesn't go this far off. I'm not sure what's happening with that. Interesting. Let me show you another one that I did earlier. Well, we're almost done now. What a lousy note to end on, though. So I think one thing that's good about this is it shows that you can still go down a bad path with this. So earlier when I ran this exact same thing, let me go find that one real quick. Let me show you one that it produced earlier to just kind of show you how this can vary from time to time. So I did this one and I did this one right here, right? Testing. I think this is the one I used. Yeah. So this is one that I did earlier. Yeah. So this is what I did earlier that worked totally fine. I asked it the same things. This is wild. So one time to the next, it can be very, very different. So I wonder if maybe the fact that I primed it and said, all right, this is a class, maybe it's like trying to do something helpful that's not actually working. I'm not exactly sure. But I actually asked for an entire Jupyter notebook that I could download. In fact, let me show you my chat. I will show you what I did when I was testing it on my own. Find it here. Download. I was playing with geospatial ideas. I was trying a lot of different things. Anyway, I think this might, no, that's a melting point. Well, anyway, I ran some things earlier that it ran perfectly fine and it was able to produce, it threw some errors. It said can't cakealize, right? So there's a cakealase structure is a type of molecular structure. So it's throwing some errors, but it actually had a really nice error detection built into the function that it wrote for me, where it was, let me find it. Keep only, yeah, so like this was a function that it wrote where it would try to form the Kekulé structure. If it couldn't do it, it would return false. So then it wouldn't actually store the erroneous ones. Anyway, I think this is probably a good place to end. It's not a great place to end. I wish it ended on a perfectly working thing, but if we spent more time on this, obviously we could get it working. So hopefully this was helpful. I really appreciate everyone coming out today. So I'll stick around for any questions. I have a little gap in my schedule after this, so I'll stick around. I'm happy to answer any questions that come up. Thank you very much, everyone, for participating today. Take care, everybody.